Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the glycoside, synthesis of the glycoside. Mainly there we are discussing thioglycosides, how thioglycoside act as a donor and what are the other derivative we can obtain by using as a thioglycosides, and it is how it can play as a role as an donor, and with the other will be the acceptor, and we are getting as a different type of the thioglycoside derivatives. That type of the thing we have discussed yesterday. What we are going to discuss today, look at the board over here, and we generally discussing about synthesis of glycosides. What do you mean by the glycosides? Everything we know that. And glycosylation with a thioglycoside donor. Glycosylation means there is a formation of the bond between that anomeric carbon atom, and we are getting as a different type of the compound that is known as a glycosylation with the thioglycoside donors. And in that we today mainly we are focusing on a two-step procedure, a transformation of thioglycoside into other type of glycosyl donor. Other type of the glycosyl donor, yesterday we have seen that a thioglycoside can be treated with the glycosyl halide, and there is a coupling takes place in the presence of different promoters, or what we can call it as a catalyst, and we are generally getting as a high yielding products in this particular synthesis, and therefore glycosides are very prominent as far as this carbohydrate chemists are concerned, and therefore today the most of the researchers paying the attention toward this synthesis. There are the many papers are published on this, and that's why we are studying at this level. So glycosylation with thioglycoside donors. So the stability of thioglycoside was only recognized as was also their very mild conversion into glycosyl halides. So that from the thioglycoside we can obtain as a glycosyl halide also very easily, with a simplification, with a high yield, a shorter time periods, and the simple reaction condition, and mainly as a high yielding and the stereoselective reaction. And hence thioglycoside were initially used as convenient precursor. Precursor is nothing but as a starting material, precursor for various glycosyl halides, and which then could be used as donor in glycosylation reaction. Glycosylation reaction means one of the sugar unit reacted with the another one by protecting appropriate hydroxyl group, and selectively we can get as a glycosylation. Number of glycosylation reactions nowadays we know that. And later it was found that thioglycoside would be activated directly by the use of chemoselective thiophilic promoter, and this discovery opened up a new field of applicable donors and glycosylation reaction. And that's why a two-step procedure, transformation of thioglycoside into other type of glycosyl donors, that is the main focusing point today. And glycosyl bromide and the chloride, as we know that glycosyl bromide and the chloride are effectively produced using bromine, also as a IBr, or chlorine also as a ICl, and nowadays often with dichloromethane Cl2 as solvent. Under these mild condition, even unstable glycosyl halide can be produced as a furacil, and the alkylated oligosaccharide bromide and the various acid labile protecting group are allowed as well. And glycosyl fluoride have been produced using numerous reagents, for example dimethyl, methyl thiosulfonium, tetrafluoroborate, DMT, SB, or NBS. And as we know that NBS are DST, NBS means N-bromosuccinamide, and which is a very good source of bromine in a free radical mechanism, as we can remember that one. So in the yesterday's lecture also we have seen that is a NIS in presence of the acetic acid. Remember here, NIS in presence of acid, suppose as a acid, or this NIS, what do you mean by the NIS? Means what? N-iodo, this is known as a N-iodosuccinamide, N-iodosuccinamide. And the structure of N-iodosuccinamide, you are the familiar with the one structure, that is a NBS. NBS is a, what is that? NBS means is a similar to here. Here I, here is a both, and therefore this also can be used in a acid, means N-bromosuccinamide, succinamide, as you might be knowing as a succinic acid, and just treated with that ammonia we will get as a this type of the N-bromosuccinamide. The structure of N-bromosuccinamide, you are already familiar with this reagent. This is a Br, this is called as a N-bromosuccinamide, and it is used as a source of bromine in free radical mechanism. And similarly this N-iodosuccinamide also has a structure, is a like this C double bond O, N, and here instead of Br, here is a iodine. That is the change, and that's why it is a N-iodosuccinamide, and N-iodosuccinamide, and it is also used as a source of iodine in a free radical mechanism. So this is the thing which we have seen just now here. And glycals, as we know that glycals and the glycals derivatives we have learned in the another case here. Just remember, this is a, here you can remember, this is a glycal. There is a carbon bond between 1 and 2 carbon atom, and that's why this type of the hydrocarbon we can call it as a glycal. And we will summarize shortly all these reactions together before we are discussing the introduction regarding that. Glycals can be obtained from phenylthioglycosides by treatment with lithium naphthalenide under condition compatible with the acid labile groups. And trichloroacetamide, that is also one of the what we can call it as a, it can be act as a donor and may be obtained by the hydrolysis of the thioglycoside thioglycoside followed by the subsequent transformation into the immediate using acetonitrile and a base. Hydrolysis have been performed using various promoters, for example AgNO3, silver nitrate, then DMS-TSB, NaOBF4 and DMTS, dimethyl methylthiosulfonium triplet in the presence of water. Sulfoxides are formed by oxidation using metachloroperbenzoic acid or dimethyl dioxirane. So there we have seen this one. So this anomeric ester have been synthesized through the action of silver or mercury carbamate NaOBF3 or in presence of acetic anhydride or NIS RCOs on a thioglycoside. And since it is possible to activate a thioglycoside in the presence of pentenyl glycoside, and it should be possible to transform a thioglycoside into a pentenyl glycosides. Let us see the scheme number 8 here, how we are getting as a different type of the derivatives we can say here by using as a thioglycoside. We are generally known the structure of thioglycoside. Here you can remember, and then this one is a SR you can write over here. SR, this is a structure of thioglycoside, and from that thioglycoside we can easily achieve this type of the compound. As we know that this is the compound where we can write this one. This is, as we know that it is a glycal, right? And from thioglycoside we can get as this type of the compound. Once again here acetyl type of the derivative OAC we can suitably get at this position, or we can convert this thioglycoside into its what we can call it as into the we can hydrolyze it, and so that we can retain that hydroxyl group, and that hydroxyl group further is converted into some other derivative like this, and this is nothing but as O then double bond NH in CCl3. You are aware of this fact that this is nothing but as a trichloroacetamide. This is a anomeric hydroxyl group protection over there, and this is a glycal, as we know that. Then now another also thioglycoside we can obtain from here. Thiochloride also we can get. Let us see here how we can get as a different derivatives over here. So like this, here also we can get. I am just representing as a partial structure over here, but you can understood this very well by observing these structures. And now, or we can get here also as a this structure O, then here maybe as a fluoride, means all kind of the halide we can. Then here we can get this type of the compound O, then here maybe a S double bond O, and then R. So these are the various derivatives If you observe this structure carefully, this is scheme number 8 over here, that is scheme number 8. So you will observe here by using as a thioglycoside. This is a thioglycosides, thioglycosides. And by using as a starting with thioglycoside, it is one of the donor, we can call it as a, or it is a precursor for deriving the different derivatives. So we can get, this is a carbon double bond over there, this type of the species are called as a glycal, right? Glycal derivative we can obtain by using, and then there is a anomeric acetate hydroxyl groups are there, and this we know that this is a trichloroacetamidate. It is a trichloroacetamidate, and where the how trichloroacetamate is obtained or derived starting from that thioglycoside. Thioglycoside we can convert into as a suitably at this thiol group into as a alcoholic, that is further converted into with the help of that trichloroacetamidate, and so that we will get this one. And now these are the what we can call it as a these are the glycosyl halides. These are the glycoside halides. These are the glycoside halides. So this is a chloroglycosides, or what we can call it as a glycoside chloride, then glycoside bromide, glycoside fluoride. So these are the different, and this also get into as a oxidized from very easily by using as a metachloroperbenzoic acid. Such type of the oxidizing agent we can use, and we will get as a this type of the different derivative. So this is all about how thioglycol can act as a donor and how it produce a different type of the derivatives. Here just now we have seen, and now the next point we are going to see, alkyl O glycoside was prepared by activation of the formed halide by a halide promoter, that is Ag2CO3 or HgCN2 in the presence of an alcohol, that is the scheme number 9 is shown. Both procedure have been used also with the glycosyl acceptors. Now let's see how we can represent that scheme over here. Let's see how we can get that type of the, because we are discussing a two-step procedure, transformation of the thioglycol into other type of the glycosyl donors. Just now we have seen some of the example. Now let us discuss another scheme over here. Let us see. This is one of the thioglycoside. Here I am showing OAC, then thioglyco. Here thiol group at axial position, or what we can call it as alpha position, and the rest of the compounds which are at equatorial position. They are always lying at equatorial position because they are the preferred in a chair conformation. Axial position is more stable, equatorial position is more stable than the axial, and that's why we are generally representing the bond representing the bond on equatorial position. Here NHAC. So that is the structure, one of the thioglycoside, and that thioglycoside suitably we can get as a derivative of that. This will be treated with Cl2, first one, chlorine gas pass over there in presence of the CH2Cl2, that is a dichloromethane, and second reagent will be added here is a ethanol, ETOH, in presence of Hg, Hgcn twice, and benzene is used as a solvent over here. Benzene used as a solvent, and they got 69% yield of the product. The product is very simple here. Instead of that sulfur, there will be this ethoxide group, and rest of the thing is remains as it is, and they are shown here, oxygen atom over here, and here just O as a OET. Instead of ACT, there is a OET. That's the change, and other thing remains as it is. O acetyl group as it is. Then this one is a ACO. Then this one OAC, and here also NH, that is a protected amine group over there, and this is the one of the best way. They got as a 69% is approximately as a 70%, and therefore this from thioglycoside we are getting as a other derivative. So these are the some of the example we have discussed over here. Now is a direct activation of thioglycoside donor. That is the point we are going to discuss over here. Direct activation. Now whatever we have seen so far discussed, let me clean the board here so that we can observe the clear structure of that remaining derivatives or thioglycoside derivatives. Now is a direct activation of thioglycoside donor. Direct activation of thioglycoside. Direct activation of thioglycoside donors. So that's the point we were discussing. We are discussing here. The first effort to use thioglycoside directly as a donor were performed mainly with mercury second salt as a promoter. Here mercury salt acting as an promoter, and it was early recognized that mercury had a high affinity for the sulfur. Mercury has a high affinity toward the sulfur functionality and effective hydrolysis of 1-thiofuranoxides using mercuric chloride as a catalyst instead of mineral acid was reported, and using the perbenzylated phenyl 1-thiobeta-D glucopyranoxide as a donor and HgSO4 as a promoter, the first disaccharide was produced, that is represent in a scheme number 11 over here. So I am showing here how one can use as a thioglycoside as an donor. Let us see that scheme over here. So I am representing that one. So this is the thioglycoside. So thio must be at this position, yes, pH. Then rest of the hydroxyl group, protected hydroxyl group, here they are lying at a equatorial position. Bn means benzyl group, benzyl, here Bn, here also OBN, here also as a OBN. So that is a simplest way to represent the protected. This is nothing but as a thioglycoside, and it acts as an donor over here, right? And now it is treated with the acceptor. What is the acceptor over here? That is a protected. This one is a protected. Now here the hydroxy group is free. Now here oxygen atom, here oxygen, this is a protected one, and now this oxygen atom, this is at axial position 1 2, they get protected by acetone, as we know that. And now this is act as an, this is a what we can go glycosyl donor. This is a glycosyl, this is a glycosyl, right? Glycosyl, and now it act as a donor, it act as an acceptor here, acceptor. And in presence of what is the catalyst or the promoter used over here is a HgSO4, that is a mercury sulfate, and the solvent is generally used as a THF, tetrahydrofuran reflux at 3 hours, and the yield which they got is a 44%. This much amount of the product is obtained. 54% yield is very low yield in this case, but this is a O glycoside we are getting over here. This is a glycosyl, this is a thioglycoside. One act as a donor, one act as another act as an acceptor, and the reaction takes place over here. And the how do you get that product? Let us see here. And now look at here. This is thioglycoside, SPH present at thiol group present at equatorial position. When this type of it act as a nucleophile which is attacking from the backside. When the backside attack takes place, the reaction is according to as a SN2 type, and as we know that SN2 type is a concerted reaction, and nucleophile is always approaching from the backside, and we are getting as a inverted product. That the thing you have to remember over there. And while writing as a product, this is the one of the thioglycoside act as a donor, another one is a glycosyl, it is act as an acceptor, and the reaction takes place between these two. And how we can show this one? So this structure you can write as it is, so simpler, and then rest of the group OBN, then they all are lying at equatorial position BNO, and now this one also has a OBN. Now what is going to happen here? This is going to link over there oxygen, so you can write this one, and now this you can join with that oxygen name. This is the structure where this one is a protected, as we know that this is a protected by 1,2 protection due to the what we can call it as with the acetone, as we know that. And this is the structure which we got, that is a O glycoside. This is a O glycoside. This is the product which we have obtained over there. This is a so simple reaction. Only thioglycoside act as a donor over here, and this is a glycosyl, where glycosyl means what? And as we know that glycosyl means there is a hemiacetal group is not present over there. So that type of the species, that is a univalent species, and therefore we are getting as a this type of the thing is a glycosyl act as an acceptor, and thioglycoside act as an donor, and we are getting this type of the compound over there. And always remember, this is a SN2 type of the reaction. SN2 type of the reaction means nucleophile approaches from the backside, and we are getting as a this, because it is present at beta position, and here we are getting as a alpha, sorry, here is a alpha derivative, and therefore O glycoside formation takes place over there. So I think these are the some of the thing we have discussed over here, that is a direct activation of the thioglycoside donor over here, and how we are getting as a product that we have discussed here with the help of some of the example. In the next lecture, what we are going to learn, the remaining part of that reaction, remaining schemes we are going to learn over here. So I think with this, let us stop today here. Remaining we will see in the next lecture. Thank you. Have a nice day.